I am going to tell you how we look for a new law of nature. Now, when you hear law of nature, you might think of something very heavy and serious. You might imagine scientists sitting in dark, dusty rooms, wearing white coats, frowning at giant books, and using words that nobody else can understand. It sounds like a big, serious job that only the most special people can do. But the way we actually do it is surprisingly simple. It is not magic. It is not a secret ritual. In fact, the method we use follows a specific process that might sound funny to you at first, because it seems almost too easy to be called science. It sounds like a game, but this game is the most powerful way we have found to understand the universe. I want to explain this to you very slowly, so you really understand how we think. Step 1. The guess first. We make a guess. Don't laugh. That is really the truth. We start by guessing. I know. In school, you are often told not to guess. You are told to know the answer. But in science, when we are facing something new, something we have never seen before, we have no choice. We don't know the answer yet. So we have to use our imagination. We look at the world, we see a puzzle, and we say, I wonder how that works. And then we make a hypothesis. A hypothesis is just a fancy word for a guess. We say, maybe it works like this. But we don't stop there. If we just stopped at the guess, that wouldn't be science. That would just be daydreaming. Anyone can sit in a chair and dream up ideas. Science happens because of what we do after the guess. Step 2, calculating consequences. After we make our guess, we have to become very strict. We have to figure out exactly what would happen if that guess were actually true. We call this computing the consequences. We say to ourselves, okay, if my guess is right, if the world really works this way, then if I do this specific thing, that specific thing must happen. We build a logical map. It is like predicting the future. If I guess that fire is hot, then the consequence is, if I put my hand in the fire, I will get burned. I am predicting what will happen based on my rule. In physics, we usually use mathematics to do this. We use math to be very precise. We don't just say, it will move over there. We say, it will move exactly 3 meters to the right in exactly 2 seconds. We need to be specific. We need to know exactly what our guess implies. Step 3, comparing to nature. Then we move to the most important part of the entire process. This is the moment of truth. We compare those calculations to nature. We run an experiment, or we look at the world, or we check our observations to see if what happened in real life matches what we guessed would happen. We take our piece of paper with our math and our guess on it, and we hold it up against the real world to see if they fit together. We ask, did the planet move where I said it would move? Did the water turn blue like I said it would? Did the ball fall at the speed I predicted? The key to science, and here is the secret, the absolute most important key to all of science. If you remember only one thing from me, remember this rule. If our guess disagrees with the experiment, it is wrong. That is all there is to it. It is that simple. It doesn't matter how beautiful your guess is. You might have the most elegant, lovely, exciting idea in the world. It doesn't matter how smart you are. You could be the smartest person in the university. It doesn't matter who you are. You could be a famous professor with prizes and medals. It doesn't matter what your name is. If your guess disagrees with the experiment, it is wrong. This simple rule is the gatekeeper. It is what keeps science honest. We cannot fool nature. We can fool ourselves, we can fool our friends, but we cannot fool nature. If the experiment says no, we have to accept it. We have to throw our beautiful guess away and start over, being unscientific. Now, this method makes it okay to make guesses, even if you aren't sure. In fact, we have to make guesses to make progress. But some people who aren't scientists think this is a strange way to think. They want certainty. They want to know things for sure 100% right now. For example, years ago I was talking to a gentleman about flying saucers and aliens. We were having a friendly argument. I told him that I didn't think there were flying saucers visiting us from other planets. He looked at me, very serious, and asked, "Is it impossible? Can you prove that it is impossible for aliens to be here?" I had to be honest. I said, "No, I can't prove it's impossible. It's just very unlikely." He got quite upset with me. He said, "You are being very unscientific." If you can't prove it's impossible, how can you say they aren't here? You are a scientist. You should deal in facts. But you see, that is exactly how science works. That man had the wrong idea about science. It is scientific to talk about what is likely and what is unlikely. It is not scientific to try to prove that everything is impossible. We almost never prove things are impossible. To explain what I meant, I told him, listen. Based on everything I know about the world, based on the laws of physics, the vast distances between stars, the energy required to travel, and the way people behave, I think it is much more likely that the people reporting flying saucers are making a mistake. I reason that it is more likely they're imagining things, or seeing a cloud, or a plane, or a weather balloon. That is a known thing. People make mistakes all the time. That is common. On the other hand, for actual aliens to come all the way from outer space, travel for thousands of years, just to fly around a farm in a saucer and not say hello to anyone, that is a huge claim. So, when I weigh the two guesses, one is very likely and one is very unlikely. It is just a better guess to say it's a mistake. We always try to guess the most likely explanation first. We check the simple answers. But, and this is important, we keep in the back of our minds that we could be wrong. If the simple explanation doesn't work, then we must go discuss the other possibilities. Think of it like looking for a lost toy in your house. Where do you look first? You check the toy box. Why? Because that is the most likely place. It's a good guess. You don't start your search by tearing up the floorboards with a hammer to see if the toy fell under the foundation of the house. That would be silly. You check the likely places first. But if you check the toy box in the closet and under the bed and it is not there, then you move to the less likely places. Eventually, you might have to check under the floorboards. But you don't start there, proving things wrong. Now, this method of guessing and testing is powerful because it allows us to prove things wrong. This is our superpower. If you have a definite theory, a clear, specific guess, we can test it. If the test fails, we get rid of that theory. We can clear away the bad ideas. We can prove any definite theory wrong. But notice something very, very important. This might sound strange to you. We never prove a theory is right. Suppose you invent a great guess. You calculate what should happen. You do the experiment, and it works. The results match your guess perfectly. You are excited. You want to shout, "I am right! I have found the truth!" Is your theory right? No. It is simply not proved wrong yet. Why do I say that? That sounds harsh, doesn't it? I say it because in the future, maybe tomorrow, maybe next year, someone might do a new experiment. They might check your guess in a way you never thought of. They might use a better telescope, or a faster computer, or a more sensitive instrument. And they might discover that, actually, your guess fails in that new situation. This is exactly what happened with Isaac Newton. Isaac Newton was one of the greatest scientists who ever lived. He guessed the laws of gravity. He explained how the planets move around the sun. He explained how the moon moves around the earth. He explained how apples fall from trees. For hundreds of years, his rules worked perfectly. Every time we checked where the moon or the planets were, Newton's rules gave the right answer. We could have said, Newton is right. This is the final truth. But after a long time, astronomers found a tiny, tiny error. The planet Mercury was moving just a little bit differently than Newton said it should. It was a very small wobble, but it was there. Newton's rules couldn't explain it. Eventually, Albert Einstein came along with a new set of rules, a new guess called relativity. Einstein's rules explained everything Newton did, plus they explained the weird movement of Mercury. So for all those hundreds of years, was Newton right? No. He just hadn't been proven wrong yet. His theory was a very good approximation, but it wasn't the whole picture. We can never be 100% sure we are right. We can only be sure when we are wrong. This makes scientists very humble. We know that everything we believe today might be improved or changed tomorrow. We have to be ready to change our minds. If we hold on too tight to our ideas, we stop being scientists. The trap of vague theories. However, there is a catch to this method. The method only works if your guess is definite. You cannot prove a vague theory wrong. If your guess is fuzzy or unclear, or if you use words that can mean anything, You can always twist things to make it look like you were right. This is a trap that many people fall into. Let me give you an example from psychology to show you what I mean. Suppose someone has a theory about human behavior. They say to you, "That boy hates his mother." You ask, "Why?" That's a sad thing to say. "Why does he hate her?" They answer, "Because she didn't hug him enough when he was a baby. He feels rejected." Okay, that sounds like a theory. So, you decide to go and investigate. You talk to the mother, you watch old videos, you talk to the neighbors. And you find out that, actually, his mother hugged him all the time. She was very loving. She hugged him every day. She kissed him. She was always there. You go back to the person with the theory and you say, "Hey, your guess was wrong. She hugged him a lot." If the theory is vague, the person will just say, "Ah, well, that is the problem. You see, she hugged him too much. She was overindulgent. She smothered him. That is why he hates her." Do you see the cheating? Do you see the problem? By having a vague theory, they can explain it either way. If she hugged him a little, that explains the hate. If she hugged him a lot, that explains the hate. No matter what you find in the experiment, their theory works. But in science, a theory that works for everything actually tells you nothing. If you can't be proved wrong, you can't be proved right either. That is not science. A theory like that is useless because you can never test it. To make that a real scientific theory, you would have to be brave. You would have to say ahead of time, clearly and precisely, if a mother hugs her child less than 5 times a week, he will hate her. If she hugs him more than 5 times a week, he will love her. That is a specific guess. It is risky. Then you can go count the hugs. You can check the facts. If you find she hugged him 10 times a week and he still hates her, then you know your theory is wrong. And knowing you are wrong is how you learn. If you can't define your terms precisely, you can't really claim to know anything about it. So, as a physicist, I like the specific guesses. I like the dangerous guesses, the ones that could fail. Where do guesses come from? Now, you might be wondering, okay, Feynman, but how do I make a good guess? Where do I get the idea? It doesn't matter. It strictly doesn't matter where the guess comes from. You could dream it up in your sleep. It could pop into your head while you are taking a bath. You could find it in a comic book. You could just make it up out of thin air. The origin of the idea is not important. The only thing that matters is that it agrees with the experiment. Why not use a computer? Now you might think, well, if guessing is the key, and it doesn't matter where the guess comes from, why is this so hard? Why don't we just build a giant computer? We could build a machine with a random wheel inside. The wheel spins and spits out random words. It could print out, "The world is made of jelly. The world is made of triangles. The world is made of cheese." Then the computer could automatically check these guesses against a list of facts we know. It sounds easy, right? It sounds like a job for a dumb person or a simple machine. But actually, guessing is the hardest part. It requires a lot of intelligence. Here is why we already know so much about the world. Science isn't starting from zero. We have tons of rules and laws that we have already tested and we know are true. We know how light moves. We know how gravity works. We know how electricity works. The problem is, sometimes we find a new thing, a new puzzle, that doesn't fit with the old rules. We have to change something to explain the new puzzle. But we can't just throw away all the old rules because the old rules work for almost everything else. We get letters all the time from people trying to help us physicists. They say things like, "You scientists say space is smooth like a sheet of paper. But maybe space is actually made of tiny dots like a checkerboard. Try that." And they think they have solved the problem. They think they gave us a great guess. But they haven't. It is easy to say, maybe space is made of dots. The hard part, the part that takes a scientist, is checking if that idea fits with everything else we already know. If you say space is made of dots, does that fit with how light moves? If space is dots, can you explain why the planets move in smooth circles and not jerky squares? If space is dots, does it break the laws of energy? Usually, as soon as you take a specific idea like space is dots and really calculate what that would mean, you find out immediately that it violates some other rule we know is true. It crashes into the facts we already have. The safe cracker, it is like you are trying to crack a safe. Imagine a big, heavy bank safe. You are sitting there sweating, listening to the tumblers, trying to find the combination. You have been working on it for years. You have figured out a lot of clues. You know the combination is 5 numbers. You know the first number is a 4. You know the second number is a 10. But you are stuck on the last numbers. The safe won't open. Then a stranger walks in, someone who doesn't know anything about safes or what you are doing. He sees you struggling and says, "Hey, why don't you try 1, 2, 3?" He thinks he is helping. He thinks he gave you a guess. But you look at him and say, that is useless. You know that the combination needs 5 numbers, not 3. You know the first number is 4, not 1. So his guess is wrong before you even try it. It doesn't fit the clues you already have. That is what it is like in physics. We are looking for a key that fits a very strange, complicated lock. The lock has a shape defined by all the experiments we have done for 300 years. We need a key that fits that lock perfectly and opens the new door we are looking at. Most random guesses don't fit the lock. They are like trying to open a door with a banana. It just doesn't work. That is why we can't just throw out random guesses. We have to make educated guesses. We have to make guesses that fit into a very tight, crowded space of things we already know to be true. We have to use our imagination to find a new idea that doesn't break the old ideas that are still working. Conclusion. So that is the game. We guess. We compute the consequences. We compare to experiment. If it disagrees, it is wrong. It is a hard game. It requires imagination to guess, and it requires honesty to admit when you are wrong. But it is the only way we have found to discover the truth about nature. So, please, if you have a theory, make sure it is specific. Make sure you can tell me what will happen if you are right. Don't be vague. Be brave. And remember, if the experiment disagrees with your guess, it is wrong. That is the rule we all have to play by.